So we got lines. For both of these, we're going to sketch the graph of the square root of these lines and then state the domain and range of our new graph. So whenever you're graphing the square root of a graph, first of all, you're going to find out where it's equal to 0 and where it's equal to 1, because those points won't change. Draw them in. There's 0, 1. I don't even know where that is exactly, but I can just sort of estimate it. Okay? You can choose some other points that you know the square root of to give yourself an idea. Like, what's the square root of 4? 2. So you know that that point would be there. It looks like you're going to get 9 right there, so I can move that to 3. Does that make sense? So I can take some values that I know and plug them in if I like. Then I can use the idea that whatever's between 0 and 1 will be slightly above, and then everything after 1 will be below. X is bigger than or equal to -2 is our domain. And our range is y is bigger than or equal to 0. If you wanted to write this in the other notation, -2 to infinity and 0 to infinity. For our second graph, where is it equal to 0? Right there. Where is it equal to 1? Right there. Doesn't look like we even get high enough to 4 that we could find a value that's nice. Maybe you know some other square roots. Does anybody have square root of 2 or square root of 3 memorized in their head? No? Okay. Square root of 2 is about 1.4. Square root of 3 is 1.7. Between 0 and 1, your graph has to be slightly above. After 1, it has to be slightly below. Now our domain here is x is less than or equal to 6. And our range is y is bigger than or equal to 0. Again, in the other notation, you could write it that way. So the graph's not too bad. Again, you start with those invariant points. Where is it equal to 0? Where is it equal to 1? You can plot a few extra points if you can see some that you know. And maybe you start memorizing square roots, like square root of 3 is 1.73. Square root of 4 is 2. That one's pretty good. Square root of 5, 2.236? Something like that. And so on. Get all your square roots memorized up to 2050 for tomorrow. And question you can do, number 5. Yeah, we have 3 examples. We'll be good. So, here we have parabolas. Same idea as lines. Nothing changes. Can you find out where it's equal to 0 and where it's equal to 1? Here it's 0, here it's 0, here it's 1, here it's 1. Then anything between 0 and 1 is slightly above. Here's 4, so that would be 2. Whoa, there we go. So in this section right there, I made it slightly above. And then after, I made it go slightly below, using the values that we have. Domain, range. So for this one, the domain is kind of interesting because it is x is less than 1 or x is bigger than or equal to 5. So that's how you would write it in one set of notation. In the other notation, x is less than -1 you could show as -infinity to 1. Greater than 5 you could show as 5 to infinity. And the way that we show or in this notation is with a big U. Ur. That's how I remember it. It means union. The range of this one is still y is bigger than or equal to 0, which you could write as 0 to infinity. For the second one, again, we find out where it's equal to 0 and where it's equal to 1. Those points won't change. Then if we look at some other values, the maximum there, it's at 9. The square root of 9 is 3. You could find out where it's 4 and estimate those values at 2. Here it's going to be above, then it's below, and then it's above again. So for the second one, our domain is between -3 and 3. And our range is between 0 and 3. And question number 8 is one you can do for practice.